Thank you, everybody, for coming. I'm going to talk about subdomain hijacking and how DevOps could be making us a little bit more vulnerable. But first of all, the obligatory, who am I? My name's Daniel Oates-Lee. I'm a co-founder of punksecurity and director. I'm a DevSecOps enthusiast. I started off my career working on the help desk, made my way onto the server team, onto the networks team, and then it was discovered that I was pretty good at hacking stuff, so they shoved me on the security team about 17 years ago. I put Automator up there because I love doing DevOps and integrating security testing into everything that I do. I am definitely a security guy. I play lots of capture the flag competitions and take part in lots of security community events. An all-round general geek. My wife, who's currently in the audience, she will attest to that. If I'm not working, then I'm generally hacking something or doing something techie. So what am I going to talk about today? Well, first of all, before we can talk about DNS subdomain hijacks, we're just going to quickly cover off how DNS works. Then we're going to cover off a couple of subdomain takeover attacks. Why should we care? And then how your organization can defend itself, including using the tool that we've created, which I'll talk about at the end. So, DNS. So, there are 13 root DNS servers out there in the world that all hold the top-level domain name service records. So, when you're doing a Google lookup, if you're not using your DNS caching, you're using the root service to go to first, it will go there first to go and find out who the top-level domain is. So the top-level domains are the .co.uk's, the .coms, the .ios, the .nets. So the root server will forward you down to the TLDR servers. Then the TLDR servers will then enumerate the next part of your domain, which is the domain that you go and buy from your domain register. So in our case, we're going to be talking about punksecurity.co.uk today. So it will be one of the DNS hosts, so that will be GoDaddy or Azure or AWS, wherever you choose to store your DNS records. And then inside these inside your DNS server, you'll then hold your records. So these will be A-class records, your MX records, your TXTs, whatever it is that you need to create to be able to make your web service works. So if we look at what access you have and what bits you can configure, you can't do anything to the root servers. To the registry servers, they will just hold an NS record, which will point you down to your own domain server. And then your own DNS server, which is public, is completely configurable by you. So I think we're all pretty familiar with that. But how does it work if your client goes to it? Well, it will go off to the root server. It will do, as we've explained, it will pull back the NS records. The NS records will point to the TLDR server. The TLDR server will then point down to your own DNS server, which will then return an IP address for connecting to a website. And these are just a couple of subdomain examples. So our domain would be punksecurity.co.uk. And www root would maybe be the subdomain for our website, and blog would be to get through to our blog server, and our docs service might get through to the document services. So let's have a look at scenario 1, which is we're using a SaaS product out on the internet, and we're going to have a look at how we could potentially do a DNS takeover attack. So, for instance, we've decided to configure up punksecurity.docs.punksecurity.co.uk, and we're pointing that off to github.io because we've decided that our API documentation is going to be held on GitHub next to our source code. So we do a quick ping, and lo and behold, we can resolve the names. We've submitted a ticket to our operations teams. They've gone and created our public DNS record, and it's now pointing off there. However, if we go to the website and we go and try and browse there, it looks like it hasn't actually been configured yet inside GitHub. Now, this is quite typical. What will happen is the developers will submit a support ticket to ask for a CNAME record. That'll be configured maybe a couple of weeks before the developers go and configure the SaaS service. And what we've started finding is that attackers are finding these DNS records that are pointing to SaaS-based products that can easily be taken over. And that's what we're going to show you now. So inside GitHub, you can go and create these things called custom domains. Now, GitHub, because it doesn't need to do any validation, you can set your custom domain to whatever you like to represent your repository. Because you own the domain and you've pointed it to GitHub, GitHub will do no validation for it. So our attacker has found that we're pointing at GitHub, but it wasn't actually serving any pages. He's now gone and registered it, and he's taken over that domain. So that is subdomain takeover number one, where we have a SaaS product, we point our CNAME to that SaaS service, it hasn't been stood up yet, and then an attacker can go and stand up a service there and start serving pages underneath your domain name. We'll have a quick look at scenario 2, and then we'll cover off why that is a bad thing in the world of DevOps. So we're going to have a look at name server delegation. So we've talked about subdomains being www.punksecurity.co.uk, which is pointing off to the web server. But we can also allow sub DNS services. So say the development team want to be able to control their own DNS records in real time. And so they request to the operations teams for them to have a subdomain of dev.punksecurity.co.uk so they can stand up their own web services, their own name servers. So the operations team will go into the main domain and they will go and create a CNAME record, which will point off to their new to the new name server. The new name server will then allow the development teams to go and create their NS records or their A-class records or whatever else that they want to go and create. But this can also have its own problems. So, if we have a quick look here, we're going to see that the operations teams are going to go and create a subdomain called dev.punksecurity.co.uk, which is what was requested. We're using AWS Route 53 here, just simply because it's the easiest way. And there we go. We've now got a name server, and we can see in a second I'll just highlight and copy the net where those names, where that new sub DNS zone is being held at dev.punksecurity.co.uk. Now we've got to go back into the parent folder to go and create the name, the NS records to point to that subdomain. But you can see there that somebody's made a mistake. They've called it developer, and this happens quite a lot. The operations teams can be under strain, and they will go and accidentally type in the wrong thing. So now we've ended up in a position where we've got dev.punksecurity.co.uk, where the developers can go and create their name servers, but we've also got this developers.punksecurity.co.uk, where the NS records, where it's pointing nowhere. So what an attacker can do now is that they can try and see if they can get Route 53 to give them those name servers so they can host their own zones. Now, we wrote a Python script for testing this, and within about 15 minutes, we were able to take over those names by just simply calling AWS CLI, and we would try and register it, and we would find that we would get the wrong name services. We'd then try again, and maybe we might get the last two, and then we'll try again, and we might get a couple more. And at this point, we can then say, right, well, we've now got a couple of these name services, so we'll just leave it the way it is, so we can start, so the attacker can start servicing DNS records as your main domain. So why is DevOps potentially making this worse? If we look at what Gene Kim talks about DevOps, he's relating to core versus context. So core is the bit that you want to develop yourselves, so like your niche little bit about your application. And context is if there's a service that you can go buy off the shelf, go buy it off the shelf because somebody else takes control of all of those patching and maintenance and looking after it. So that might be something like a web service or an email server. You don't want your developers building a brand new web server when all you want to do is build like a nice little product that will sit on top of it. We also use these idea of ticketing systems. So when a developer wants to release something or create a new service record or something like that, they will typically go and create a ticket. It will then sit in a queue. It'll take a few weeks for the operations teams to potentially carry it out. Then it will go back to the developer, and it might not be in that sprint. It might be in a couple of sprints' time. So we end up having this period where we've requested a CNAME or an NS record to be created, and there's a period of time where it's then not implemented, where an attacker can go and take over it. We're still doing quite a lot of click-opsing as well. So where we're using Terraform or infrastructure as code, the operations teams aren't still quite up to speed with using Terraform or infrastructure as code, and they will just go copy and paste what was in the previous, maybe pull request or whatever they've done previously, and they might make a mistake. And delegation is obviously one of the things that are causing us a little bit of concern as well, because we are trusting that the development teams are creating these NS records as they need them and destroying them as well when they don't need them. So you might be thinking, well, so what? We can create some names. Some attacker can take control of a name, a DNS name. What's the problem with that? The problem is, and the URLs that are up on the site now are ones that were actually publicly taken over and have been publicized on HackerOne, is that we can create credible now phishing links. So like signupuber.com. We're telling our users to be really careful about what we click on and make sure it looks legitimate. But who would have thought that signup.uber.com would have been an illegitimate domain name or subdomain? And it would have passed through any URL reputational checks as well, because uber.com is trusted. Which will then lead us to credible email addresses, like helper.signup.uber.com, where a phishing attack could be sent out and ask users to go and reset their passwords or to go and verify a password change. However, the most scary bit are loosely scoped cookies. And this is the part where the hackers, the pen testers in the room will be a bit more interested. Because if you can take control of a subdomain and the website has a loosely scoped cookie, you can steal the parent's cookie. I'm going to show you how that works. So what happens is we have a main website running at punksecurity.co.uk, and we've got a couple of subdomains. The cookies at the parent that are created at the parent domain will feed down automatically if they are not what we call scoped. So if we look at this website, we've got 3 cookies on our Punk Security website. We've got 2 by Calendly, and we've got 1 from Cloudflare. If we have a little look, if you look at the domain, it's got a full stop before the domain name. That indicates a loosely scoped cookie, which means it is possible to use that cookie for that domain and any child domains. So if we go back to our previous NS name server attack, we created developers accidentally, and our evil attacker has now gone and taken over developers' name servers and stood up www.developers.punksecurity.co.uk. So anybody that logs into Punk Security now, and we send them a phishing link, when they click on that link, we're going to be able to get hold of their cookies, which could include authentication information. So that nicely leads on to my third demo. And, yep, there it is. So what we're going to do here is we're going to use example.org, which is just a local web service we're going to just open up the development browser so then we can go and drop in a cookie. Now, normally you would log into a website or you'd be able to go and start up a web service and create your cookie. You might be able to get a cookie out of it that way. But we decided just for the sake of ease that we do it this way. So we've created an authentication cookie and we've put the word secret in there just to show what would happen. Now, currently, it's only scoped for example.org. So to make this loosely scoped, we're going to need to put a full stop in front of it. So we put a full stop in front of it. Now, the attacker has also taken, this scenario here is if we've lost our name server. So there's that NS server record. So an attacker now is going to go and create a subdomain website, get that stood up and running, and potentially send a phishing link through to a user to click on a link and connect to subdomain.example.org. And when they click on that, lo and behold, you can see there the cookie has just come through our website for the authentication cookie with secret inside there. So we've been able to take that, and all we've done is sent them a web link. So this is one of the reasons why we need to be careful about what we're doing with our name services and why we need to think about what we're doing with our public DNS. So how can we defend ourselves? One of the biggest things that we're going to have to start doing is periodic reviews and audits of what we've got inside our public DNS zones. How many people in this room can tell me that they know exactly every single public DNS record that's in their zone today and what it's used for? How many people think there are dead DNS records in their public DNS zones today that aren't pointing off to anybody or aren't being used? What would happen if somebody went in and deleted all of your public DNS zone records? Do you think you'd be able to quickly recover from it? Probably not. And it's one of the lowest things that we think about as well. It's not on the top of the agenda because it's not one of the Gucci things that we think about. But because we're moving to this idea of DevOps and using cloud services, we need to be able to create DNS records that are pointing to these cloud services. So we need to start thinking about looking after them better. Another way of being able to defend against it is to sign up to a bug bounty program like HackerOne and paying some bug bounty guy $200 for finding a faulty DNS record. Sounds brilliant. We did also find that there was one SaaS service out there on the market. For $1,000 a month, they will scan your domain for subdomain takeovers. And that, to me, sounds value for money. We can also ask our pen testers. We could ask our pen testers to start checking our external DNS records. But pen testers are they're overloaded anyway with time constraints and what have you. So all you're going to do is degrade your pen test potentially a little bit more. We could move to infrastructure as code. We at punksecurity, we do that. All of our DNS settings, all our DNS records, our external network load balancers, all the WAFs and everything are all configured and controlled under Terraform. So we know exactly what's been deployed and we can go through the pull requests and we can validate that what we're pushing out is correct. However, I'd like to talk to you about a brand new tool that we have created called dnsReaper. Incidentally, there are badges, stickers along the front which you can help yourselves to. What we came up with this conclusion with dnsReaper is it should be relatively simple to be able to check these DNS zones. So we had a look at how we could potentially do that, and we came up with a simple solution. It's a little Python script that went and checked your DNS records and then goes and checks that the target host is actually up and alive and it's not pointing to something that's dead. So dnsReaper will run as a Docker container, or you can download it as a Python script and run it locally. You give it a list of your domains, or you can configure it to log into your name server. So currently we support GoDaddy, Azure, AWS, Cloudflare, and there are a couple other ones. I can't remember them off the top of my head, but I'll show you them in a minute. We then, when we're testing these domains, we've written signatures. So when you go to GitHub, rather than just looking for the word 404, the web pages typically get a return a 200 HTTP code. So what we're doing is we're scanning through the actual page that's returned and look for key signatures, which then give us a confidence level to validate that that page is susceptible to being taken over. And then we give you a nice little report on the screen, a CSV or a JSON file, however you see fit, to be able to digest it. Now, the use cases for dnsReaper are for auditing your DNS configurations. For those that in the audience that want to go and start making a little bit of money on the side, dnsReaper is pretty good. You could go sign up to a bug bounty program and use dnsReaper to help you earn some dollars. We don't ask for anything, so don't worry about that. Or you could just use it as part of the pipeline to check that what you've deployed has actually made sense and that you haven't got something lingering around that shouldn't be there. Now, I know that there are a couple of people in the audience today who have used dnsReaper and who have found a few DNS zones that were susceptible to DNS takeovers. It seems to be picking up on popularity. There are some large banks that have also been using it just for checking, doing manual checks. So feel free to use it. So what does it look like and where can you get it? You can go to GitHub, go and download the source code. Or we do nightly builds where we resolve any security issues and push out a new image every night to Docker Hub. We also do a full documentation suite. So rather than you just having to guess what IAM permissions you need to give dnsReaper, we've created like IAM rules that you can copy and paste in. So then dnsReaper has only got access to what it requires. And with every good security tool, we've got some of the world's best ASCII art and make it look pretty. Because, yeah, that's the only way to use a security tool, isn't it, at the command line. So as you can see here, we can do DNS zone transfers. You can download all of your DNS records if you don't trust dnsReaper into a file and just get it to scan it. It can log into Cloudflare, it can log into AWS, it can log into Azure, DigitalOcean. It can even check simple Linux bind servers. So rather than you having to know every single DNS record, you can just get dnsReaper to log in and then it will go and check all of those zones for you automatically. And if we point it at punksecurity.co.uk, we can see here, I don't know whether you guys can see at the back, but we can see that we've got, it's found developers.punksecurity.co.uk is potentially susceptible. So you get this idea that we are giving you a confidence rating as well. So if we say it's potential, it means you need to go manually check it. If we give you a confidence of confirmed, that means one of our signatures that we've written has checked, done that manual check for you, and it is susceptible to being taken over. So it will tell you exactly the score there. Now I'm going to do two shameless plugs really quickly. We do have 3 other tools as well. We've got SMBeagle, which we designed as a ransom readiness audit tool. You can run it as a low privilege user on your network, scan your whole network, and it will then document every file and folder inside every single network share you can see, and put it into Elastic so then you can understand what you would lose in the event of ransomware. For the pen testers in the room, people are beginning to use this now for scanning the network, because what good IT admin would ever put a hard-coded password in a software share for deploying software out? So we've got the red teamers in the room that are using it as well. We've also got Secret Magpie. Secret Magpie will scan your Git repos for secrets, and it combines the use of Trufflehog and Git leaks. But what it will do is it will scan your entire organization in one go and then give you one HTML output with all of the secrets in there and links it through into the GitHub repo so you can go and do a manual verification. And we've also got PwnSpoof, and this is used for threat hunter training. So it'll generate you a web server attack log file with a unique attack inside there every single time. We are currently redeveloping that to also include firewall logs, WAF logs, Cloudflare logs, and potentially some more. We're also coming up to 2 years old at punksecurity, so we're running a DevOps and DevSecOps CTF. That'll be held on May the 4th when we are actually 2 years old, so it isn't a made-up date, it is a proper date. And rather than the traditional CTFs where you go and hack a website, we've gamified DevOps and DevSecOps tasks. So we're trying to teach people the reason why it's a bad idea to give Docker containers privileges, or how you can abuse a CI pipeline to steal a secret from another system, or going and finding secrets in a Git repo, those kind of things. But I will open the floor now to questions about domain takeovers. Yes. We wouldn't necessarily check to see if you were masquerading as a different website, but what we would do is we would check we would go and see if it's like a CNAME that's pointing off to like GitHub or Azure apps or something like that. We will do a curl request off that and see if it matches. If it doesn't match and we're not getting what we maybe would expect to be in like a normal web page, then we will just raise that as a potential takeover attack, and you'd have to go and do a manual verification. Yes. Yeah, it's a Apache 2 MR2 license. So everybody can use it. And all of our tools that we've made open source, dnsReaper, SMBeagle, Secret Magpie, PwnSpoof, they're all free for anybody to use, even in a commercial sense. So, yeah.
Any other questions? Yeah. You okay to shout?
I haven't seen them doing anything, to be honest. I think the vendors take it a stance as you are responsible for configuring your own DNS services. Very similar to if you're using a SaaS platform, their responsibility will only go up so far, and it's then up to you how you configure that. So I haven't seen any vendors taking this on and being able to help people with it. Maybe they might. Maybe somebody might decide that they want to integrate dnsReaper into being able to add that as a value-add service, but I haven't seen anybody doing anything like that at the moment.
Any more? Yep.
Yep. None. Unfortunately not. Because this is being done at a DNS level, all you're doing is you're looking at a record and it's being pointed off to a web service. Now, if you're a web service, like we were discussing, if it's like a name server, if those name servers aren't stood up, TLS isn't going to be able to protect you on that. If you're looking at pointing it at a cloud service like GitHub or Azure apps or AWS's versions, then again, they will have TLS enabled, but it won't help because you might not have anything already set up there, which will then allow the attackers to go in and stand something up on your behalf for you. It's very kind of them to go and stand up a web service and pretend to be you, but yeah, that's nothing.
Thanks very much. Listen, that's all we've got time for. Again, let's show our appreciation for Daniel.